A C program always starts with a skeleton that the compiler expects. Think of it like a house. You need a foundation, walls, and a roof before you can live in it. In C, the foundation is the header files, the walls are the function bodies, and the roof is the main function. Headers, they bring in definitions for standard library functions, for example print_malloc. Without them, the compiler would not know what those names mean, just like trying to use a tool you have not bought yet. Main function, this is the entry point, the front door of the program. The operating system calls main when the program starts. Its prototype is usually int main void or int main int arg char star argv array. The return type int tells the operating system whether the program succeeded 0 or failed non-zero. Braces, they are the walls that separate one block of statements from another. Every opening brace must have a matching closing brace. The compiler uses them to understand the scope of variables, just as a fence defines the area where a pet can roam. Return statement, return 0 at the end of main sends a status code back to the operating system. Many simple programs omit it. The C standard implicitly adds return 0 if the closing brace of main is reached. Example minimal program include stdio.h int main void, open brace, print hello world, return 0, close brace. The preprocessor runs before the real compiler starts, much like a chef preparing ingredients before cooking. It reads lines that start with hash and performs textual substitutions. Hash include less than file.h greater than colon, copies the whole content of the specified header file into the source file. Think of it as pulling a whole recipe booklet into your notebook so you can use its steps. Hash define name value object like macro replaces every occurrence of name with value. Example, hash define pi 3.14159 makes the token pi act like the number 3.14159. It is similar to a shortcut key that expands into a longer phrase. Hash define macro left parenthesis arg right parenthesis expression, function like macro, performs a text substitution that can use arguments. Example, hash define square left parenthesis x right parenthesis left parenthesis x right parenthesis times left parenthesis x right parenthesis right parenthesis. The preprocessor does not evaluate anything, it merely writes new code. Conditional compilation #if, #ifdef, #ifndef, #else, #elif, #ndif allows you to include or exclude parts of code based on compile time conditions. It is like a light switch that decides which rooms of a house are lit. Example, #ifdef debug newline print left parenthesis double quote debug info backslash and double quote right parenthesis semicolon newline #ndif. These directives do not produce any object code themselves. They only change what the compiler eventually sees. A function in C is a reusable piece of code. Think of it as a small machine you can plug into a larger assembly line. Prototype, the declaration that tells the compiler the function name, return type, and parameter types before its actual body, appears example int add open parenthesis, int a comma int b close parenthesis. It is like a blueprint shown to the foreman so they know how to connect the machine later. Definition, the actual body where the work is done. Example, int add open parenthesis int a comma int b close parenthesis, open brace, return a plus b semicolon close brace. Call when you use the function. Example, int sum equals add open parenthesis 3,4 close parenthesis semicolon. The program jumps to the function, executes it, then returns. Int sum equals add open parenthesis 3,4 close parenthesis semicolon. Recursion, a function that calls itself directly or indirectly. It works like a set of Russian nesting dolls. Each call creates a new smaller copy of the function environment, until a base case stops the nesting. Example, factorial. In fact open parenthesis int n close parenthesis open brace. If n less than or equal to 1 return 1 semicolon return n times fact open parenthesis n minus 1 close parenthesis semicolon close brace. Inline functions, a hint to the compiler to replace the call with the function body, directly eliminating call overhead. It is like writing the recipe steps directly into the main instruction list. Instead of referring to a separate booklet syntax, inline int max open parenthesis, int a comma int b close parenthesis, open brace, return a greater than b question mark a colon b semicolon close brace. Modern compilers may ignore the hint if they think it is not beneficial. Inline int max open parenthesis, int a comma int b close parenthesis, open brace, return a greater than b question mark a colon b semicolon close brace. Keypoint prototypes must match definitions exactly same return type same number and type of parameters mismatches, cause compilation errors, or undefined behavior at runtime. The journey from source code .c to an executable .out or .exe passes through four main phases. Imagine building a car. First you design the blueprint preprocess, then you cut metal parts compile, then you assemble the parts assemble, and finally you attach the wheels and paint link. Preprocessing CPP handles hash include, hash define, hash if etc. output file.i optional intermediate C after macro expansion. Compilation CC-C translates the preprocessed C code into assembly language, output file.s. Assembly as converts assembly into machine code stored in an object file. Output file.o object file contains binary code and symbol table. Linking LD takes one or more .o files and library archives .static, .so shared and resolves all symbol references. Produces the final executable .out, program.exe or a shared library .so or .dll. Typical command chain simplified. gcc-eprog.c-oprog.i hash preprocessing only. gcc-sprog.c-oprog.s hash compile only stops after assembly output. gcc-cprog.c-oprog.o hash compile plus assemble produces object file. gcc-prog.o-oprog hash link to make executable. File extensions you may see. .c source code, .i preprocess source, .s assembly code, .o object file binary not yet linked, .a static library archive collection of .o files, .so or .dll shared dynamic library, executable .out.exe. Understanding the phases helps you locate bugs. For example, a macro error shows up at preprocessing, a type mismatch at compilation, an undefined symbol at linking. When the compiler produces an object file.o, it also creates a symbol table, a list of names, functions, variables that the file either defines, provides code or storage, or references needs from somewhere else. Static symbols local, visible only inside the object file. The compiler marks them as local because they are not needed by other files. Analogy: a private room in a house only the owner can enter. External symbols global, marked as undefined in one object file and defined in another. They are like public doors that other houses can use. The linker's job is to match each undefined external symbol with a definition. File1.c, static integer counter equals 0, static only file1.c can see it. Integer add 1 function taking integer x returns x plus 1, external other files may call it. File2.c, extern integer add 1 declaration of external symbol. Integer main function returns add 1 of 5. During linking, add 1 from file1.o satisfies the reference in file2.o. Libraries, a collection of object files packaged together. Static library.a, the linker copies needed object files into the final executable. After linking, the code is part of the executable and no external reference remains, similar to baking all ingredients into a single cake. Dynamic shared library.so or .dll. The executable contains only references, the actual code is loaded at runtime. It's like having a kitchen appliance that you plug in when you need it. The linker also performs relocation, adjusting addresses so that each piece of code knows where its variables and functions live in memory. If two object files define the same external symbol, the linker reports a multiple definition error, akin to two people claiming ownership of the same house. Understanding symbol resolution helps you structure code, static versus extern, and avoid common linking problems. Syntax/lexical errors, preprocessing or compilation. Error expected semicolon before right brace token. The compiler saw a close brace but was missing a semicolon earlier. Look at the line number indicated. Often the real problem is on the previous line. Warning: implicit declaration of function print. You likely forgot include stdio.h. The compiler assumes a return type of int, which is unsafe. Type mismatches. Error: incompatible pointer types assigning to int pointer from char pointer. You tried to store a char pointer string into an int pointer. Check function prototypes and casts. Error: too many arguments to function sqrt. You passed more arguments than the prototype expects. Undefined reference link time. Undefined reference to my helper. The linker could not find a definition for my helper. Possible causes. Missing source file in the compile command. The function is declared static in another file, making it invisible. Forgetting to link a library, for example -lm for math functions. Multiple definition. Multiple definition of global counter. Two object files both defined a non-static global variable with the same name. Resolve by making one static or moving the definition to a single file and declaring extern elsewhere. Missing library. Cannot find -lsl. You ask the linker to link with -lsl, but the library is not installed or the linker search path -l is wrong. Linker script relocation errors. Relocation truncated to fit rx86_64_32s against data. The code is trying to address data with an instruction that cannot hold the full address. Often occurs when compiling 32-bit code for a 64-bit target. Diagnostic tips. Always read the file name and line number displayed first. They point to the source of the problem. Pay attention to the type of message, error versus warning. Warnings may still produce a runnable program but can hide bugs. Use -ww all -ww extra to get more helpful warnings. For link errors, run nmfile.o to list defined and undefined symbols. Verify that the missing symbols appear in some other object or library. Clean the build, make clean after changing header files. Otherwise, stale object files may cause confusing errors. Explanation: let's implement a classic quadratic equation solver that finds the roots of a x squared plus bx plus c equals 0. The formula is x sub 1 comma 2 equals negative b plus or minus square root of b squared minus for a c all over 2a. The term delta equals b squared minus for a c. The discriminant tells us the nature of the roots. Include standard input-output header. Include math header. Void solve quadratic taking double a double b double c. Integer main returning void. Declare double a b, c, print enter coefficients a b, c colon. If scan formatted as double 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 into a b, c does not equal 3, then print a standard error input error and return 1. If a equals 0.0, then print a standard error not a quadratic equation. A must not be 0 and return 1. Call solve quadratic with a b, c return 0 success. Void solve quadratic taking double a double b, double c. Declare double delta equals b times b minus 4 times a times c, the discriminant. Declare double 2 a equals 2 times a. If delta greater than 0, then compute square root of delta as sqrt delta. Compute x1 equals open parenthesis negative b plus sqrt delta close parenthesis. Divided by 2a. Compute x2 equals open parenthesis negative b minus sqrt delta close parenthesis. Divided by 2a. Print 2 real roots x1 and x2. Else if delta equals 0, then compute x equals negative b divided by 2a. Print 1 real double root x. Else compute real part equals negative b divided by 2a. Compute imaginary part equals square root of negative delta divided by 2a. Print complex roots real plus minus imaginary I. Compilation steps: Step 1, preprocess optional c.i file, gcc-equad.c-o quad.i. Step 2, compile to assembly, gcc-s quad.c-o quad.a. Step 3, assemble to object file, gcc-c quad.c-o quad.o. Step 4, link with the math library required for square root, gcc quad.o-lm-o quad. Running the program, $/./quad. Enter coefficients a b c colon 1 minus 3 2. 2 real roots 2.000000 and 1.000000. Key points to notice for the exam: include math header provides prototype for square root. Without linking with -lm, the linker will omit undefined reference to square root. The program checks a equals 0 to avoid division by 0, a common edge case. The discriminant handling demonstrates conditional logic, not preprocessor conditionals but normal if-else. All return paths from main use integer code 0 for success, 1 for error, matching the C standard. Explanation: exam questions on C program structure often test whether you can identify where an error occurs in the build pipeline, predict the outcome of code fragments, or fill in missing pieces. Typical formats: phase identification question, at which compilation phase does the line hash define max 100 get processed? Answer: preprocessing. Error prediction. The code reads, int main open brace print open quote high backslash and close quote semicolon return semicolon close brace. The compiler will emit an error, return statement with no value in function returning int. Code completion, the blank should be the word extern. The program declares a static integer counter initialized to 0, increments it twice and prints the value. It prints 2. The linker reports undefined reference to foo, because the object file that calls foo was not provided. The macro expands to 1 plus 2 times 1 plus 2, which evaluates to 5. How to prepare colons. Memorize which file extensions belong to which phase. Practice reading compiler messages. They often contain the line number and a short description. Write short snippets that illustrate each concept, such as static versus extern, inline, and recursion. Use pen and paper to simulate the preprocessing step, expand macros. Remember that the main function must return int, and that return 0 signals success. Explanation: when you write code for an exam, the evaluator looks for clarity, correctness, and style that makes the program easy to read and to grade. 1.0. Consistent skeleton: always start with the same structure: hash include angle bracket stdio.h angle bracket. Hash include angle bracket stdlib.h angle bracket // if you need dynamic memory, /* function prototype // int my underscore function left parenthesis int x right parenthesis semicolon, int main left parenthesis void right parenthesis left brace, /* body /. Return 0 semicolon, right brace, /* function definition // int my underscore function left parenthesis int x right parenthesis left brace return x plus 1 semicolon right brace. 2. Comment sparingly but meaningfully: write a brief comment above each function describing its purpose, and inline comments for non-obvious logic. Example: // compute the discriminant of a x squared plus bx plus c double discriminant, left parenthesis double a comma double b comma double c right parenthesis, left brace return b star b minus 4 star a star c semicolon right brace. 3. Modular design: put each logical piece in its own function. This reduces the size of main and shows good decomposition - a point many exam rubrics award. 4. Use const for immutable parameters: helps avoid accidental changes and signals intent. 5. Avoid global variables unless required: if you must use them, mark them static to limit scope, and add a comment explaining why. 6. Error handling: for every input operation, check the return value and print a clear error message before return 1 semicolon. This shows robustness. 7. Naming conventions: use lowercase with underscores, e.g. solve underscore quadratic. Consistent naming makes the code self-documenting. 8. Indentation and braces: use a uniform indentation, 4 spaces is common. Place opening brace on the same line as the function header dash. This is the style most textbooks adopt. 9. Testing edge cases: if the problem mentions special cases division by 0, negative discriminant right parenthesis. Write if statements that handle them and comment why they are needed. 10. Compilation command and answer sheet: some exams require you to write the exact command you would use to compile, e.g. gcc-wal-wextraquad.c-lm-o quad. Including this shows you know the linking step. By following these habits, your code will be clean, easy to grade, and demonstrate a professional approach that many interviewers and teachers value.